Hello, this is William from Visual Components. In this video, I'm going to show you how to route products by material. One way to route products by material is to use components in our eCatalog library. Another way is to use component authoring tools and API to create your own routing rule logic. I'm going to show you how to do both ways. I am assuming you have the basic understanding and skills of layout configuration and component modeling, so it will be pretty straightforward in this video. So pause, rewind, and watch it however many times you need to. To get started, I'll build a simple layout in the 3D world. I'll go to my eCatalog panel. Under Models by Type, I'll use Component Templates. I'll add a Conveyor template and a Split Conveyor template. The Split Conveyor allows you to divert products out of one of these two interfaces. With the side, right now it's left, but you can turn on the Turn Right option here to switch the side of this interface. But I'll switch it back to be on the left side. Now connect the split conveyor to the conveyor here at its end. I'll copy and paste this conveyor and connect the conveyor to each end in our split conveyor. So paste in another one. Very simple conveyor line. Let's now feed it with products. In my eCatalog panel, under Models by Type, I'll use Feeders. The Advanced Feeder allows me to create custom properties and components that it creates. So I'll connect the Advanced Feeder to the beginning of my conveyor line. By default, the Advanced Feeder will create using a distribution. You can find the distribution by clicking this button here, or just select the Advanced Feeder and click this note icon here. You can find some documentation about how the distribution works. So the first 4 columns are reserved for making the components, so you can have their probability of how often they're created, property, color, and so on. The next columns are those custom properties you want to add to the components. They can either be a type of real number, an integer, or string. This is your header row, so that's used. These are like your columns. Let's add a new column with a comma, call it product material. For this entry here, let's give its product material the same value as its color. So here the color is red, comma. Use single quotes to indicate a string value. Give it red. Next entry, comma, single quotes, value of purple. Last entry, comma, single quotes, value of white. So these values will be assigned to these properties. Run the simulation, stop it here, select one of the parts. In the Component Properties panel, you can see it was added or given that product material property with that value we wanted it to have. Let's now use this property in our routing rule for our split conveyor. So reset, select the split conveyor, go to the Component Properties panel, and in its routing rule, let's delete the existing rule of cyclic and add a string table rule. Notice there is not a rule to check the material property of a component, so you can use one of these property table rules here. You can check a Boolean property, integer, real number, or string. We created a string property in the components. The variable or property name was product material. That's what we want to check. By default, if the component does not have that property or any matching value in this column, we can give it a default route. And let's do that. Send it to outport 1. Now add a new connection. Let's say if the product material is white, let's send it to outport 2. So we have a very simple string table rule that checks a component property called product material. If the component has a product material property, but doesn't have a product material of white, it will use the default route here. Run the simulation. And notice this component, it's purple. This one's white, so that's why it goes to this conveyor. These are red, and that's why they go here. If you stop the simulation, select one of these red cylinders, you can see its product material is red. And in our routing rule for the split conveyor, we're not checking red, so by default it's being sent to outport 1. Remember, if the component does not have the property, we're using the default route 2. Let's add a new connection or rule and say if the product material is red, let's also send it to outport 2. So this purple block here, it's going to go to this conveyor, but these white sheets, they'll go there, and these red cylinders, they'll also go to this conveyor. So that's just one way to use components in our eCatalog library to route products by material. There are other components that you can use besides the Advanced Feeder to add properties to components, but I won't talk about those right now. Let's actually delete the advanced feeder and replace it with a basic feeder. So this just creates one part. We have these cylinders. You can see that its material is beige. So how can we create a material rule for our split conveyor to route the products based on the material property of a component? At this point, I'm going to use the component authoring tools. So if you are an Essentials user, you could follow along or create your own add-on. I'll select my split conveyor, go to its routing rule, and delete what I just did. So now we have an empty rule. Parts can flow into our split conveyor and be contained there, but they can't be transferred out. We don't have a rule for telling the part where to go or where to send it. Let's now go to our modeling tab. In the component graph panel, you can see the properties and behaviors of the split conveyor. It has paths, which are connected to the ports in our routing rule. With the routing rule, you can add more ports or connectors. You can delete them as well. If you select a port, it has its own properties, which you can see here. It can either be an input port, flow in parts, an output port, flow out parts, transfer in, transfer out. If you're using some type of proxy, sometimes you can make a port, do both receive and send. But in our case, I'll switch this back to be an input port. We do have a lesson on our Academy that talks about routing rules in detail, so I'm not going to cover that anymore. So in our routing rule, if we want to give it a new rule or logic, I'm going to use a Python script. So I'll add that behavior now. Make the text bigger. We don't need to use the on signal or on run events, so I'll just delete them. And what we're working with is the data you can see here in the component graph panel, but in code. So the first thing we want is a component, so I'll write comp equals get component. This is the component of this Python script. I'll then get my routing rule. So I'll use the component object to get a behavior by name. And the name of the behavior is routing rule, which you can see here in the component graph panel. Let's now print out the value of that variable I created called routing rule. Compile the code. You could press the Control and S key or reset the simulation to compile the code, or just press this button. And in the output panel, we get feedback that a routing rule behavior is a type of VC routing rule object. So to learn more about this object in Python API, click the Help tab, access the Python API reference, and find that VC routing rule topic. So it's a behavior. You can flow parts in and out of it, and it can also be used as a static container. It has some properties and some methods, but it also has an event. So when a part or product is transferred into the routing rule, you can get feedback about that and also call functions or tasks that you want to perform. So let's use this onRoute event. You have to use it with the object. So routing rule dot onRoute. When this event is triggered, we can call a function. I will call my function route by material. So when the event is triggered, the script will look for a function of this name. It doesn't exist, so we have to define it. I use the DEF or definition keyword, followed by a space and the function name. Remember, this event gives us some data or some arguments. So the first argument is going to be the connector or port the part came from, the component itself, that part, and which behavior it came from. Then create a colon, and that's it for the definition or signature of my function. I now have to define what it does. Let's first get the material of the component. So I'll write material equals component dot material. Let's then print the name of that material. Compile the code. And what we're testing now is that when a part is transferred into our routing rule, the event is triggered and it's calling our function that is getting the material of that product and printing its name. So here comes that product. And yep, you can see we don't have any logic for transferring it out of our split conveyor, so it is containing the part, and we printed its material name of beige. So if I double click the part here to select its component, you can see we got the component, we got its material, and we printed its name, which you can see here is beige. Let's reset. And if we go back to our Python API reference, we can see we have this method called setTarget. So you can set which port you want to transfer the part to. So it's an index value, and remember with lists and tuples, other types of data sets, that the index value usually starts at 0. So 0, 1, 2, and so on. In the component graph panel, select the split conveyor. You can see its routing rule has 3 ports right now. So this is index of 0, 1, and 2. Let's transfer the part or set the target to be this port here, this connector. So that'll be an index value of 1. Let's create a variable in our function called index and give it a value of 1. We'll then use the routing rule behavior or object to call that method of set target. And I'll pass it a value of our index variable, which is 1. So if we were to run the simulation, the parts should go to this conveyor, not this conveyor. And that's what happens. So why is that though? How did I know that the parts would go to this conveyor? Well, in the component graph panel, you can see the routing rule behavior. It's ports, so this is the index of 1, out port 1. If you select it and go to the properties panel, you can see that it's connected right now to out 1 path behavior in the split conveyor and its input port. So the part is being transferred to that path. And that path, if you select it here, you can see it's defined, but it's also being used by this out 1 interface. So if you select the interface and go to its sections, you can see right now it's currently connected to out 1 path, and we're sending things out of that path we transfer the part to, which is connected to the path in this conveyor. So that's how this is working. The same thing is true for the other output port here. It's just connected to a different path and using a different interface. So if we want, let's change the index value to 2, compile our code, and now the part should go to this conveyor. And that's what happens. Now, if you have many products and you have to check many materials, getting the material every time here might be a bit cumbersome. So what we can do, let's actually create a list of materials we want to check. So I'll create a variable called left rule, and I'll make it a list. So create the variable, set it equal to a list, which is defined using square brackets. And we'll give it string values. So let's say some name of materials: red, white, blue. And if the material in that part, if its name is in our list, then let's change the index value to 2. But by default, let's have the index be 1. So if the material name is in our list that we defined here, we'll route the part to this conveyor here. Otherwise, it will go to this conveyor. If you want, you can compile the code by clicking this button, but remember, you can reset the simulation to compile the code and then run the simulation. So yeah, this part has a material of beige, so it's not in our list, so that's why it's going here. But easy to fix. Let's add beige to our list. Compile the code, run the simulation, and because that material is in our list, the part is being transferred there. So pretty simple. You may want to give a user some options for defining the materials it wants to check in its routing rule. So let's actually create a component property in our split conveyor. So select the root node, go back to the modeling tab. We'll add a string property. And I'll keep it the name. You can think of a better name, but I'll call this materials left or route. Materials left. We don't need to rebuild any geometry, so I'll clear that out. For the materials themselves, we can add that here. So I'll say red, white, blue, and beige. Close this out. And if we select the split conveyor as a component, you can see there's that string property we added. So now let's check that property value in our script. So instead of defining a variable here, we can get rid of it. And we'll use our component object to get the value of its route materials left property. So if we compile the code, This does have a flaw, and you'll see why. So it still works because that material name is in the string, you can see. But if you want to get a list of values from the string value we had here, what you can do is you can say left rule equals comp route materials left. So we'll just cut this, paste it here. But then we'll split them using this built-in function in Python. And we'll just separate the values if they're separated by a comma. You could use a different delimiter. Some people separate values using semicolons, some use colons, but we'll just use commas because that's what we have here. We separated the materials names with commas. So now we use our left rule. So if the name is in that list, put them over here. So very easy to check. And with this property, I actually allowed the user, or whoever uses this component, to edit the value while the simulation is running, which is why I have this checkbox selected here. So if we want, let's actually delete beige from our list. And yep, I've now routed in real time the parts to this conveyor just by changing this property value. Didn't have to do any changes to my code or anything like that. Let's now reset. And having this one property here, you might have a really long list. So one option is to use a note behavior and read in the values there. So let's go to our split conveyor component and add a new behavior that is a note. And let's access the note, open it up. You would have seen something like this earlier with the advanced feeder. It has several notes. But here our note will be simple. We'll just have a long list of separated values using a comma of the material names. So let's go to our component and get that route materials left property. Just copy all these values and paste them here. And instead of checking the component property, let's get the note behavior. So left rule, what we'll do is we'll first get the note. So it's a behavior, use the component object to get the behavior. By name, it has the default name right now of note. And to get the value of the note, you have to use its note property. And then from there, you can split it up using the same way I showed you earlier. So we could say note.split, comma. I don't remember if that will give you a list or not. Let me see. When you get the value of the note, because this is technically free-form text, but it's simulation, it's easy to test. So let's compile our code. We didn't get any errors, and that's because the event hasn't triggered this call to this function yet. So if we run the simulation, beige is not in our note, so it's routed out here. But if we want in our script, we can print out our left rule. Compile the code. Wait for the first part to enter. And yep, you can see it gives us a list. So red, white, blue. And then in our note, we can change this to be beige. You can see now the parts are routed there, and we get an updated value for our list. So let's get a bit crazy and remove beige from our note. And you can see that we did have an update issue. So technically our note behavior didn't update, and that's why in our script it's still routing the products over here. But notice when we close the behavior, it did update the behavior's value, its notes value. And that's why the parts are now being transferred over here, and the list was updated. So just be aware that if you're using a note behavior versus a component property, if you want to import a CSV file or Excel sheet, you can of course do that as well. Have some table of data for creating and routing parts. It's no problem. But we can do better. Let's go back to our script. Oop, gotta make the text bigger again, sorry. For our left rule, we don't need to print out anything anymore. We can just get the current value of our note. You could also try calling this update method here in case you want to edit the note in real time to see if you can change the values. But let's keep it like this. And you're probably wondering, how can you use the custom routing logic that you have versus the one that you define in the behavior using the user interface? Well, it's easy to do. Let's create a simple Boolean property in the component. Give it a name, route by material. Make sure it's visible. You don't need to rebuild anything. And you probably don't want to edit it during the simulation, but for now, let's just say that the value of the property is true. And close this out. So in our onRoute event, when that is triggered and it calls our function, what we want to do, make sure first, is that we do want to route by product material. So if the component, its property, route by material, is true, you could define the condition like this, or you could say, write it out longer like this, is equal to true. But this actually is not getting the property object itself, it's just getting its value. So if it returns a true value, then we know we can do this. But we want to see if that value is false. So if the value is false, we want to return. We don't want to do anything else here. So if we compile the code, select our split conveyor. Right now, route by material is turned on, so our script should still work. Parts are going here. Let's go back to our note real quick. Open it up. Add beige. Close it out. And whoop, just in time. Now the part goes here. So now, let's turn off route by material. Oh, and now we're stuck because we don't have any other rules for transferring the part. So you could use scripting, you could also use a mix of the GUI. So let's do that now. For the routing rule in the component, I'll add a cyclic rule. I'll only transfer parts to ones that are connected via interfaces that we defined here. And let's have outport of 1. So by default, we'll transfer there. And then let's also transfer part to outport 2. So if we're not routing by material, we'll transfer part to this conveyor and the next one to this conveyor and repeat the cycle. Notice route by material is turned off, so that's what happens. So here and then here, let's turn route by material on, and now the parts are going to this conveyor, not this one, because we define the route by material in our script here. So just a couple of different ways how you can use, Python scripting, use some lists or values with events, and some event listener function to route a product by material. You could then expand that to use a note behavior. You could also use a component property, and you can also use a component property or condition to test whether or not you want to route products by material. And you can do all this in real time while the simulation is running. Alright, this completes the video. If you have any more comments or questions, please feel free to visit our forum at forum.visualcomponents.com. And as always, have a wonderful day.